This is Chem 110, and this is Unit 2, and we are beginning with Segment 2. In the last segment, we talked about the basic components of the atom or the element, protons, neutrons, and electrons, and what they contribute to the makeup of that atom. Then you were told to commit some of the symbols and the names to memory. So you need to have done that in order to move on. Okay? Now your periodic table is arranged in a very specific way. Okay? And the reality of it is they are organized according to what is called periodic law. And periodic law is cyclic repetition of chemical behavior. Okay, now I'm going to let you know that this is a huge gift, because if there is repetition of chemical behavior, you don't have to commit a whole bunch of things to memory. You just have to learn a few things. Okay? Now, as a semi-tangential aside, I like to tell people that the person who is credited with this is Dmitri Mendeleev. And two lessons here. Credit doesn't mean that it's the only person who has thought of this idea. He just got to the patent office, so to speak, sooner than anybody else. The other thing about Dmitri Mendeleev is that as a young person, he was considered very inept as a student. And in fact, he couldn't even get into the university. He had to have his mother, I believe, or parent, convince the university to take him. And yet, it turns out that he is credited with one of the most useful tools in chemistry that there is, and that is the periodic table of elements. Okay, page 3. Within the periodic table, there are groups and periods. So the groups go down the periodic table. The periods go across. So we need to label this periodic table, or the one that you have in front of you, so that we're all consistent. 1A, 2A, and then come all the way over here and start numbering 3A, 4A, 5A, 6A, 7A, 8A. Okay? This group here in the middle is called the transition elements, or we can call them the D block, or we can call them the B groups. Okay? These down here are called inner transition elements, and we don't talk too much about them except for uranium, so I'm just going to sort of ignore them for the moment. Periods go across, so you might say period 1, period 2, period 3, period 4, period 5, 6, and 7. And this is germane to what we're doing as we go along. Okay? Now, within the periodic table, we want to look and see where the metals, nonmetals, and metalloids are. In the classroom, or if you have a different periodic table, it might be color-coded for you. What you'll get for your exams is something similar to this, except it won't have the names on it. Okay? What you'll notice on your periodic table is there's a heavy stair-step line. Okay? To the left, in general, is metals. The exception is hydrogen. Hydrogen is not a metal. It's just grouped with these metals for a specific reason. Over here in this corner are the nonmetals. And along this stair-step line are what we call the metalloids, except for aluminum. Aluminum is decidedly a metal. Okay? So if I ask you which groups are metals, you would say most elements, perhaps, left of the stair-step line. Metalloids, upper right corner. Metalloids are along the stair step except aluminum. Okay. Now, some of the groups get names, which I said already with the transition metals, but within that, some get special names. Okay? Now, this is helpful to us because we want to make generalizations because of the way they are in groups. Okay, so the groups, these are similar. These are similar. These tend to be similar. Similar, 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 and so forth. And there's a specific reason for that. So we want to know where the metals are, the nonmetals are, the metalloids are, and then we want to know the names. Okay, so alkaline metals are group 1A. Okay, 1A, or sometimes you see a periodic table with Roman numerals. So if I asked you some examples of alkaline metals, it would be anything in this group except hydrogen, because that's not a metal. So we could say lithium, sodium, potassium, rubidium, etc. Okay, so this is why you have to know the symbols. If you don't know the symbols, then you don't even know what I'm talking about. Okay, alkaline earth metals are 2A, or Roman numeral 2A. So that would be anything in this group. Okay, so beryllium, magnesium, calcium, etc. Transition metals are right here in the middle, so we could call them again, we could say those are in the middle. We could call that the D block. We could call them B groups, however it is that you want to say that. And there are a ton of them. A ton of them that you needed to commit to memory, and just a ton of them in general. Okay, so examples: titanium, chromium, iron, gold, mercury, etc. Okay, halogens are over here, 7A. 7A, or Roman numeral V11, is 7. Fluorine, chlorine, bromine, iodine, astatine is not usually included. Okay, so fluorine, chlorine, bromine, iodine. And then last is the noble gases, and that is 8A. 8A, or Roman numeral V111A. So helium, neon, argon, krypton, etc. Okay, so you have to know the symbols in order to speak the language moving forward. Okay, properties of metals, nonmetals, metalloids. In general, metals are solid at room temperature. There's only 2 elements. If you have a color-coded one, you will see that these tend to be in blue, these tend to be in black, and those are mercury and bromine, and you should just commit that to memory. Which ones tend to be gases at room temperature? Well, noble gases, those are the ones that tend to be in red. Okay, so those are the ones that are typically non-metals. Okay, so hydrogen, oxygen, nitrogen, etc. They do appear in life in pairs, and we'll talk about that as we go along. Which ones tend to conduct electricity? Electricity forms through flowing electrons. That's how we get electricity. So you have to have something that is going to lose electrons. And this is hugely useful to remember this. In general, metals will tend to conduct electricity, which means they have flowing electrons, which means metals will lose electrons. And that is something that you should be sure you understand. Okay? So if I ask you to name an element that would have properties in similar in theory to lithium, you would choose something in the group. So I might say sodium or potassium. If I want something to be similar to calcium, I would choose something in the group, not in the period. Okay, so maybe manganese or strontium. Okay? Next page. If I want something similar to oxygen, I would choose something in the group, and so forth.